All right, we are continuing our labeling and studying of characteristics of the periodic table. Today we are going to talk about all the non-metal groups and their characteristics. So let's get open. If you don't have it open already, pause the video, get this guy going. But we are on this other section of the periodic table here. We're going to talk about metalloids, other nonmetals, halogens, and noble gases. So we left off with those other metals. Now we need to talk about metalloids. I'm going to do those in purple. So metalloids are another segment that is, there's certain ones that fit into this. So it's kind of a zigzag pattern here. So your metalloids include boron, silicon, germanium, and I don't want to cover up too much, so I'm trying to make it so that I can still see all the other colored lines. Arsenic, antimony, all these elements that have at least two purple parts around them. Tellurium, and polonium. These guys are your metalloids. All right. So metalloids, that name kind of makes you think they're kind of metals. That's exactly what the idea is. All right, so your metalloids have some properties. Let's get those typed in here. So metalloids, they really are a combo of a metal and a nonmetal. That's why they kind of surround that metal-nonmetal distinction line. All right, so they have properties of metals and nonmetals. So some can conduct electricity, others can't, or they might be able to conduct electricity in certain situations. Oh, I just lost my box here. I'm going to rewrite this. Spread that out. So they have properties of metals and non-metals. All right. They are definitely, they tend to be more brittle than metals. But less brittle than solid nonmetals. Not all nonmetals are solids, so that's one reason. So, they're kind of in this in-between state. Something that is entirely unique to our metalloids is the fact that they are semiconductors, right? So this is a key term for you to know. Those of you that are really into computers and things like this is especially why, like processors and things like that are made out of silicon, right? So semiconductors have this ability to conduct electricity under certain conditions, right? So that allows us to send signals and not send signals and things like that. And then some are lustrous, shiny. Remember, that's what it means. Others are dull. Like silicon is actually really dull, but germanium actually has kind of a shininess to it. This is antimony. All right, there's your metalloids. Actually, I've got some room and pull that down there. All right, now on to our nonmetals. We're going to start by talking about these things. All right, so a lot of these are opposites. Right, nonmetals are insulators. All right, prevent conduction. All right, they are brittle, break easily. They have low melting and boiling points. And they form negative ions. All right, so a lot of nonmetals, especially because of the low melting and boiling points, they end up being liquid or gas at room temperature. There's some, like carbon, if you're writing with a pencil. Carbon is a solid at room temperature, but many of them aren't. Like oxygen, which we breathe. All right, so other nonmetals. First group, let's do, trying to think what's going to be actually easy for you guys to read the typing of. Let's do this kind of bluish gray here. This is another kind of zigzag group. So we've got carbon all the way over to oxygen. So it's kind of this little chunk here that butts up against our metalloids. Selenium. I don't want to cover up any numbers, and I'm trying to make sure you can still see the purple line. That way you'll be able to tell these guys all apart. All right. There's your other nonmetals. And I need to put a box here. All right, so your other nonmetals. Put this up here. Other non-metals. All right, many of these are gases at room temperature. So like oxygen definitely is, nitrogen is, but carbon, phosphorus, sulfur, and selenium are not. Definitely, these are brittle if they're solid. And they are insulators. Especially because these tend to be the most solid nonmetals. These are the things that tend to be in things that we use to be insulators. All right, next category, halogens. We're back to finally having just a single column. Let's do maroon. All right, so halogens. Oh, the color change didn't take off. There we go. Don't want to cover up the numbers. There we go. Scoot it over one spot. So there's our halogens. And halogens have their own unique properties. So since we're back to a single column, we actually are back to having a valence electron pattern. So these guys have 7 valence electrons. All right, these guys, kind of like your alkali metals, are too reactive to be pure in nature. All right, and they tend to react, they like to react with alkali metals. All right. Let's see. Another interesting one is bromine. It's liquid at room temp. All right. And our last classification, let's do this in gray. This last row, right, these are our noble gases. Right, and the noble gases are known for having 8 valence electrons, which is actually a full shell. So what that means is that these guys don't want any extra electrons. They don't react. They are non-reactive. So you actually always find these pure in nature. That's the unique trait of your noble gases. They do not react. All right, and actually they were among the last to be discovered because they are also colorless, odorless, and kind of invisible to the naked eye, so to speak. All right, so that's all of the group classifications. We are going to add some overall periodic trends to this as well. So hold off on turning it in for the extra credit until you have that information on there too.